For 7 years, GTA Online took 6 minutes to load, and the entire reason was one JSON file. One file, 10 megabytes, a shopping catalog. 6 minutes, on a machine that could then render a photorealistic city at high frame rates. Story mode on the same disk? Just over a minute. Click online, go make a coffee. Maybe 2. This is the game that earns billions. Players complained from its 2013 launch straight through to 2021. 7 years of memes, refund jokes, and forum threads. Rockstar shipped heists, islands, entire expansions in that time. The loading bar never made the patch notes. Then one anonymous player got fed up. No source code, no debug symbols, no contact inside Rockstar. Just a task manager, a free profiler, and the patience to look. He found the bug, patched it from outside the game, and cut loading times by 70%. Rockstar investigated, confirmed everything, shipped his fix, and paid him $10,000. And here's the detail that should haunt every engineering team, the one we'll get back to. By his estimate, the fix was one developer's day of work. One day, against 7 years. By the end of this video, you'll know exactly what was hiding in that file, why a decades-old C function quietly turned it into a monster, and how to check your own code for the same trap. Let me set the scene. Early 2021. A programmer who goes by the handle T0SD, pronounced Toast, picks GTA Online back up after a break. He wants to finish some of the newer heists. His PC is no monster. An aging 8-core AMD chip from the olden days, as he put it, a budget SSD, a decent graphics card. In other words, the kind of hardware most real players actually own. He clicks online, and the ritual begins. 1 minute passes. 3, 5. On his machine, 6 minutes, flat. Story mode, same game, same disk, about 70 seconds. So he does what engineers do. First, check if someone already solved it. The internet offers folklore. It's the peer-to-peer networking. It's just a huge game. Try this menu trick. The tricks save 30 seconds, tops. A community poll he finds suggests most of the player base quietly lives with the same pain. Millions of people, 7 years, no explanation, just a shared shrug. So he decides to get an explanation himself. But first, you need to see the sheer scale of the thing that was broken. And here's the part that makes this story almost unbelievable. This wasn't some abandoned side project running on goodwill. This was one of the most profitable entertainment products in history. Grand Theft Auto V launched in 2013 and became one of the highest-grossing entertainment products of all time. Not just among games. Among everything, films included. Revenue measured in billions. And the part of it that kept earning wasn't the story you play once. It was GTA Online. A persistent criminal playground where players grind and spend, and where in-game money can be topped up with real money. For Take-Two, Rockstar's parent company, GTA Online became one of its main revenue engines. Every apartment, every jet, every weapon skin sold for years on end. Cumulatively billions. Now hold those two facts side by side. On one side, a money machine unlike anything the entertainment industry had ever built. On the other, its own front door, jammed shut for 6 minutes, every session, for 7 years. Because think about what a loading screen actually is for a business like this. It's the queue outside the shop. Every minute of it is a paying customer, standing at a locked door, holding their wallet. And players didn't pay that toll once. They paid it every session. Boot the game? Load. Join a friend's heist? Load. Get disconnected? Load again. 6 minutes wasn't an entry fee. It was rent. And it wasn't just veterans paying it. Every new player's first evening, every giveaway weekend, every review in progress, they all began with the same 6-minute stare at a slowly panning skyline. First impressions, 6 minutes late, millions of times over. The complaints were never quiet, either. 7 years of forum threads, negative reviews, launch day jokes that never stopped being current. The loading screen became part of the game's identity, a punchline with a progress bar. People built routines around it. Click online, do the dishes. Click online, walk the dog. When your customers start scheduling housework around your software, that's not anecdote. That's telemetry. Rockstar, meanwhile, kept shipping. New heists, new businesses, new islands. The content pipeline was world-class, the updates relentless. The front door stayed broken. And to be fair, nobody outside the company knew why it was slow. Maybe it was unavoidable. Maybe a persistent online city just takes 6 minutes to wake up. That was the accepted folklore. Folklore is comfortable. It converts a bug into a fact of life, a thing you schedule around rather than fix. And nobody profiles a fact of life. Even hardware didn't really save you. Players with high-end machines reported faster loads, sure, but still measured in minutes. Whatever this was, it wasn't waiting on your SSD. So here's the question worth holding for the next 20 minutes. How does a company with world-class engineers and effectively unlimited budget not look behind its own loading screen for 7 years? The answer is not incompetence. It's something more uncomfortable, and odds are it lives in your organization too. But to see it clearly, first we need to watch one tired player with a task manager do the looking. February 2021. Toast opens the crudest diagnostic tool in existence, the task manager. No setup, no license, no source code required. Just one question. What is this machine actually doing for 6 minutes? The first minute looks healthy. Disk activity, CPU spread across cores, textures and assets streaming in. The shared stuff both game modes need. Story mode would be nearly done by now. Then online mode keeps going. And here's where it gets weird. For the next 4 minutes, one core is pinned at 100%. The other 7 sit idle. Disk usage, none. Network, a blip, then basically silence. GPU 0. Memory, flat. The machine isn't loading anything, downloading anything, or rendering anything. It's thinking, furiously, about something. Toast's reaction in his write-up is the correct one. What is it doing? Mining crypto. One core, flat out, touching no resources. That's not loading. That, he wrote, smells like really bad code. Next question, what's running on that core? A normal profiler wants source code, or at least debug symbols, hooks into the program's own names. He has neither. This is a shipped, protected, commercial binary. But there's an older trick that needs nothing at all, stack sampling. Freeze the process. Write down where the instruction pointer is standing. Unfreeze it. Wait a few milliseconds. Repeat, thousands of times. If the program spends most of its time in one place, most snapshots land in that place. Like figuring out where a roommate spends their day by taking photos at random moments. Crude, but statistics doesn't lie. He uses a free, half-forgotten profiler called Luke Stackwalker, unmaintained for a decade. No function names. So he eyeballs raw addresses and groups the nearby ones by hand. And the pile of snapshots says, not one hot spot. 2. To see what those addresses hold, he needs a disassembler. He borrows a friend's copy of the industry standard one, joking he can't afford it. And here Rockstar fights back. The binary is obfuscated. Open it, and you get gibberish, scrambled on purpose against cheaters, pirates, and modders. The workaround is beautiful. Scrambled code can't execute. Whatever the CPU actually runs must be deobfuscated in memory first. So don't read the file on disk. Dump the memory of the running process and disassemble that. He does. And in that dump, one of the 2 hot addresses arrives with a label attached. A real name, surviving in a stripped binary. The function eating minutes of CPU is strlen. strlen might be the most boring function in the C language. It measures a string's length by walking it, byte by byte, until it finds the terminator at the end. That's the entire job. Let that sink in. 4 minutes of loading, in a product that earns billions, and most of it was spent inside a function whose entire job is finding a 0 byte. One step up the call stack sits a label reading vscan_fn. Almost certainly the guts of scanf, the C standard library's text parser. So the game is parsing text. A lot of text, apparently. He attaches a debugger, steps through the parsing, and dumps the buffer the game keeps chewing on. Outcomes: JSON, 10 megabytes of JSON, roughly 63,000 item entries. Somewhere inside one of the biggest games on Earth, for minutes of pure CPU time, we're going into reading one config file. Which raises the real question: how? How do you burn 4 minutes on 10 megabytes? First, let's calibrate. 10 megabytes of JSON is nothing. A decent parser gets through it in a fraction of a second, even on modest hardware. This file was taking minutes. That gap is the whole mystery. The file itself is the net shop catalog, the master list of everything you can buy inside GTA Online with in-game money. Every car, every apartment, every weapon upgrade. 63,000 entries. One entry pulled straight from the running game. A cryptic key, a price of 45,000 in-game dollars, a category, weapon mod. One paint tint for one gun. 63,000 of those. The game reads that file with scanf. Standard C library function, scans formatted text. Handed a string and a pattern, it extracts the next value. It's old, it's everywhere, it's battle-tested. A completely normal choice. But on this C runtime, scanf hides a surprise. On every single call, the implementation first converts your string into a file-like object, and along the way, it calls strlen. It measures the entire remaining string, every time. So, read one value, then walk 10 megabytes to find the terminator. Read the next value, walk 10 megabytes, minus a handful of bytes. Repeat. 63,000 entries, multiple values each. Here's the metaphor that makes it click. Imagine reading a book under one rule. Before each word, you must flip through every remaining page to count them. Then read one word. Then count every page again. That's not reading. That's cardio. And it's exactly what this loading screen was doing to that catalog, at CPU speed, on every single boot. Computer science has a name for this shape: quadratic. O of n squared. Its defining feature is that it hides. Small input, invisible. Double the input, 4 times the work. 10 times the input, 100 times the work. And that's the key to the 7 years. In 2013, the catalog was small, and this parser was probably close to instant. Then every update added items. Cars, businesses, whole islands. The file grew, and load time grew with its square. The bug didn't appear one day. It matured, release by release, item by item, for 7 years. Slowly enough that no single update ever felt like the one that broke it. And to be fair to whoever wrote this, Toast himself said he couldn't blame the developer. No documentation warns you that scanf calls strlen. It's an implementation detail buried inside the C runtime, invisible from above. So that's bottleneck 1. Most of those 4 minutes spent measuring the same string over and over. But remember, the profiler found 2 hot spots, and the second one is worse. Not technically worse, morally worse. After parsing each item, the game stores it in an array. Fine, but first, it checks whether that item is already in the array by walking the whole thing, comparing hashes 1 entry at a time. Item 1, 0 comparisons. Item 1000, 1000 comparisons. Item 63,000, 63,000 comparisons. Sum the series, n squared plus n over 2, and you get roughly 1.98 billion checks to load a shopping list. Nearly 2 billion comparisons, and every one of them was pointless twice over. First, every entry in that file is unique. Duplicates cannot occur. Second, the list is empty when loading begins. There is nothing to be a duplicate of. And the punchline, sitting right there in the disassembly. The code already contained a function that inserts directly, no checking. The fast path existed. The slow path got called. For 7 years. So, can any of this be fixed from outside? Understanding a bug in someone else's binary is one thing. Fixing it, with no source code, no build system, and no permission, is a different sport. This is where Toast's plan gets audacious. He can't edit Rockstar's code, but he can get his own code into the game's process. The technique is DLL injection. Load a small library into the running game. and start redirecting traffic. The redirect is called hooking. When the game calls strlen, the call lands in Toast's replacement function first. His code decides, handle this myself, or pass it through to the real thing. For the parser, he doesn't need to rewrite anything. He needs a cache. When strlen measures a very long string, remember where it starts and where it ends. Next time strlen is called with a pointer inside that same string, don't walk millions of bytes. Subtract 2 numbers. Return. The marathon becomes arithmetic. That's the entire trick. Wait for a long string, cache its end, answer from the cache, and when parsing is nearly done, the hook removes itself. The rest of the game never notices. The duplicate check gets even less ceremony. His hook doesn't optimize it. It skips it. Every parsed item goes straight into that direct insert function Rockstar's own code already contained. Is skipping a safety check reckless? It would be, if the check did anything. The list starts empty. The entries are unique. Deleting work is always safe once you've proven it's not work. When the final catalog entry lands, the hooks disable themselves and the DLL unloads. In Fix Out, the game never knows it had help. The whole fix is a small proof-of-concept library, spare evening code, shipped for free by someone with no access, no budget, and no obligation. Nobody assigned this ticket. There was no ticket. Now, the benchmark. Same aging machine, same measurement, from the Rockstar logo to standing in the game world. Stopwatch running. Baseline, 6 minutes, flat. Patch only the duplicate check, leave the parser alone, for minutes 30. Patch only the strlen cache, 2 minutes 50. Patch both at once. 1 minute, 50 seconds. Down from 6 minutes. A 69.4% cut. And yes, Toast computed the exact percentage and wrote nice next to it. An anonymous player, standing outside a locked and obfuscated binary, had just deleted 70% of a 7-year-old loading screen. He published the whole investigation, code included, plus 1 sentence that traveled around the world. This shouldn't take more than a day for a single dev to solve. So how does this happen at one of the richest studios in gaming? The answer is not find the bad programmer. It never is. Let's count layers instead, because there are 5, and you'll recognize all of them. Layer 1, a naive parser. Someone, probably years before launch, needed to read a config file and reached for scanf in a loop. Standard C, correct output. On the small catalogs of 2013, effectively instant. A defensible choice. Layer 2, the hidden cost. Nothing in scanf's contract mentions strlen. That behavior is a private decision inside 1C runtime. The developer wrote code that looked linear, and the library quietly made it quadratic. Layer 3, unbounded growth. The catalog wasn't a fixed asset, it was a garden. Every update planted more items. Code that was fast against the data of 2013 was never remeasured against the data of 2020. Layer 4, misplaced caution. That duplicate check is defensive programming, protecting against a corruption that could not occur on a list that started empty at a cost that grew with the square of the catalog. Care, aimed at the wrong target. And Layer 5, the big one. In 7 years, the online startup path apparently never got profiled on a real consumer machine. Or if it did, the result never became anyone's problem to fix. How is that possible? Because a loading screen is nobody's KPI. It doesn't crash. It doesn't breach. It doesn't dent a revenue chart you can point at. No alert fires at minute 5. It's pure friction, distributed across millions of strangers. Inside a studio, every incentive points at shippable things. The new heist has a deadline and an owner. The loading screen has neither. It's everyone's annoyance and no one's job. And there's a crueler mechanism underneath. The people who build the game don't experience it like players do. Dev machines are fast. Test builds use trimmed data. And anyone who does sit through the full load, daily, for years, stops seeing it. If you want proof that it's cultural, look at story mode. Same engine, same machine, same disk, loading in a fraction of the time. The slowness wasn't the game. It was one path through the game that nobody owned. There's a name for that: normalization of deviance. The abnormal thing arrives slowly enough and stays long enough that it gets reclassified as normal. Every engineering disaster this deep has that pattern somewhere in it. No single layer here is a scandal. A standard function, a growing file, a cautious check, a missing dashboard, a num routine. Stack all 5, and you get a 6-minute monument standing in front of a billion-dollar product. Remove any single layer, and this story never happens. And the cheapest layer to remove was the last one. One person, one afternoon, one profiler, pointed at the most boring screen in the product. So, what did 7 years of not doing that end up costing? The post went up on February 28, 2021, under a title that undersold it: How I Cut GTA Online Loading Times by 70%. It topped Hacker News, then spread to seemingly every gaming outlet on the internet. Millions of players finally had their answer, and it was worse than the folklore. Not a heavy game, not a stress network. 7 years of waiting on a string measuring loop and a duplicate check that checked nothing. Now Rockstar had to look, and to their credit, they did. The response wasn't a denial. It wasn't a lawsuit against the person who just disassembled their binary in public. It was an investigation. 2 weeks later, the company put out a statement. After a thorough investigation, we can confirm that player Toast did, in fact, reveal an aspect of the game code related to load times that could be improved. Corporate translation: he's right. On March 16, 2021, 16 days after the blog post, Rockstar shipped Title Update 1.53. The line for PC players read: improvements to PC loading times. 5 words, closing out 7 years. And right below it, a sentence you almost never see in AAA patch notes. Thanks to Toast for his contributions around this part of today's title update. A gaming giant, crediting an anonymous reverse engineer by handle. Toast ran the benchmark again that day. Same aging machine, same measurement, from the logo to fully in-game. The official fix held. His verdict, added to the post, fully fixed. Toast approves. Then came the money. Rockstar runs a bug bounty program on HackerOne, but it's scoped to security and privacy vulnerabilities. A slow loading screen doesn't qualify. There's no payout category for "you embarrassed us with arithmetic." They paid him anyway, $10,000, as an explicit exception to the program's rules, for a bug that stole nothing, except minutes of every player's life, every single session, for 7 years. Depending on your mood, that $10,000 is either a genuinely classy gesture or the cheapest performance audit in corporate history. Both readings are correct. Because run the exchange rate. Millions of players times years of 6-minute loads. That is an astronomical pile of human time spent watching clouds render. The diagnosis cost one outsider a few evenings and a borrowed disassembler. And notice who found it. Not a staff engineer with source access. Not a vendor with a support contract. A player with a task manager, a stopwatch, and a reason to care. Sometimes that's all the org chart a bug ever needed. And the estimate that started it all was never disputed. One developer, one day. That's the gap this whole story fits inside. 7 years on one side, one working day on the other. If you're enjoying these engineering postmortems, subscribe. One real story, at this depth, every week. Now, don't go anywhere, because there's a thread left from the cold open. I told you the fix was one developer day, and you heard that as a story about Rockstar. It isn't. The same trap is very likely sitting in your code right now. Here's the thing about the scanf trap. It was never Rockstar's invention. That behavior, calling strlen on every single pass, lives inside the C runtime itself, which means the same landmine sits under any code that calls scanf in a loop over a big buffer. And scanf in a loop is a stock pattern. It's in textbooks. It's in tutorials. It's in the Stack Overflow answer somebody on your team pasted in 2014 and nobody has touched since. The deeper trap isn't one function, though. It's the shape, a helper that looks constant time but is secretly linear, called inside a loop. That's how you build an accidental quadratic. And it passes every test, because tests use small data. Modern languages don't make you immune, either. Every ecosystem has functions that look cheap and quietly aren't. String concatenation in a loop. Regex compilation per call. An ORM query per row. Different costumes, same quadratic monster. The duplicate check has cousins everywhere too. A contains call on a list inside a loop. In Python, exon list. In Java, list.contains. Harmless at 100 items. A catastrophe at 63,000. The fix is a hash set, one line. And notice where these bugs concentrate. The startup path. Startup code runs once per session. It never shows up in steady-state metrics. It never pages anyone at 3 a.m. And everybody who could fix it has learned to alt-tab through it. Here's the homework. Then, and it costs one coffee, profile your startup, your app boot, your test suite setup, your CI pipeline, your container start. Sample it once, and look at the top function. So, honest question, when did you last profile a startup path? Not the hot loop you're proud of, the one with the benchmark suite. The boring part before it. If the answer is never, you're in excellent company. Rockstars. Worst case, you spend 20 minutes confirming everything's fine. Best case, you find your own 6-minute monument, and you get to be the person who quietly deletes it in a day. That's what one player did to one of the biggest games on Earth, from outside the building, with spare evenings, no source code, and no permission. The method fits on an index card. The only rare ingredient was refusing to believe that slow was normal. The loading screen is faster now. The blog post is still up, still teaching. And Toast is still anonymous, $10,000 richer, and owed a quiet thank you by several million players. 7 years. 6 minutes. 1 JSON file. 2 functions. The expensive part was never the CPU time. It was the assumption, shared by millions of players and one world-class studio, that slow was simply what loading looks like. Somewhere in your stack, right now, something is slow enough that everyone has stopped noticing it. A build, a boot, a pipeline. That's not a fact of life. That's a bug with seniority. Go find it. More stories like this every week. If this one earned it, subscribe. Thanks for watching.